All right, Algebra 2, October 19th through the 23rd. Make sure you have lesson 14 in front of you. That way you can do what we need to do with this lesson. All right, so really quickly, we're going to kind of run through this. I am going to use the graphing calculator some. If you have one at home, that's great. Use it. If you don't, then unfortunately you're going to have to do things by hand. So it says an engineer is designing a roller coaster for younger children and has tried some functions to model the height of the roller coaster during the first 300 yards. She came up with the following function to describe what she believes would make a fun start to the ride. H of x is equal to negative 3x to the fourth plus 21x cubed minus 48x squared plus 36x, where h of x is the height of the roller coaster in yards when the roller coaster is 100x yards from the beginning of the ride. So in other words, we're 100 yards from the ride, and this is what's going to happen. Answer the following questions to help determine at which distances from the beginning of the ride the roller coaster is at its lowest height. Alright, so what I did is I graphed this on a calculator. If you don't have a calculator, you would have to graph it by basically putting values in for x and figuring out what y would equal. It says, does this function describe a roller coaster that would be fun to ride? Well, this is a representation of what this roller coaster would look like. And you'll kind of see that it starts up and drops and then up and drops. So now, this is a personal question. Does this look fun? You need to answer this. It's a yes or a no question. Alright? And it's based on your thoughts and opinions. So go ahead and answer this first question the way you would feel. Does that look like a fun roller coaster? Or for me, it doesn't, because I don't like things that drop suddenly. So it's your choice. Can you see any obvious x values from the equation where the roller coaster is at the height 0? Alright, so in other words, I want to know, can I look at this and see any place that x would be equal 0? The height is 0 where x is 0. If you will look, you can see it crosses at the 0, 0. So the height is 0. When x is 0. Because at that value, each term is equal to 0. In other words, my coordinates here would be 0, 0. Alright, so it says using a graphing utility. So at this point in time, it says graph the function h on the interval of x, or 0 is less than or equal to x, is less than or equal to 3. And identify when the roller coaster is 0 yards off the ground. So when I graph this, alright, so I need to go in and I need to talk about when x is greater than or equal to 0, but less than or equal to 3. Alright, so I'm going to open my window. Alright, and it says to make it less than 3, or less than or equal to 3. Alright, so I'm going to do that. Alright, so this is what I got. So it says, see if we can figure out when the roller coaster is 0 yards off the ground. So I want to look at the lowest point on my graph when my x value satisfies h of x is equal to 0. So in other words, when x is equal to 0, what am I figuring out about or when my y is equal to 0, what is my x value? Well, because I want h of x to equal 0, in other words, when is my y equal to 0? I will see that is at when x is 0. Alright. Then I'm going to come over here and I can, let me zoom in just a little bit. And then I can do a trace. And it shows me that when y is 0 is also at x is equal to 2. Alright, let's do another trace. Let's keep on doing my trace here, because I feel like there's another spot, because I can look, and then I notice that my y is also 0 at 3. Alright, so it occurs when x is 0, 2, and 3. What do the x values you found in part C mean in terms of distance from the beginning of the ride? Well, if you remember, it told us that this was a graph of when the roller coaster is 100x yards from the beginning of the ride. So that means the distance represents zero, because 100 times 0 is 0. 100 times 2 is 200. And 100 times 3 is 300 yards. So in other words, I'm at my lowest point at the beginning of the ride, 200 yards from the beginning, and 300 yards from the beginning. Alright? And you can kind of see that on your graph. You can see that on your graph because look what happens. It goes up, down, down. So I can see my lowest points there. Why do roller coasters always start with the largest hill first? So have you ever thought about this? Why do we start with the largest hill first? Well, they start with the largest hill first so they can build up speed. From gravity. To help propel the cars through the rest of the track. biggest heel at first because they need to get enough speed to finish. So you think about it. The bigger the heel, the more speed as they're coming down, which is going to allow them to finish up through that rest of the track. Verify your answer to part C by factoring the polynomial function h. Alright? So let's think about factoring this polynomial. I can probably figure out by my graph that x minus 3 is a factor. So if that's the case, then I would have to do long division. But I'm going to start with looking at this, and I can pull a negative 3x out. So when I pull a negative 3x out, that leaves me with x to the fourth minus 7x cubed plus 16x squared minus 12. And I actually did not take out my x. So this would be x to the third. This would be x squared. And this is just going to be x. So it should look like this. Let me rewrite that. I just factored out my 3. I forgot my x to factor it out. Alright, so then I can look at my graph and see that x minus 3 is a factor. And when I do long division, this is what I end up with. And I can factor that into x minus 2, x minus 2. Alright? So then if I set everything equal to 0, negative 3x equals 0, x minus 3 equals 0, and x minus 2 equals 0, divide by negative 3, x equals 0, add 3 to both sides, x equals 3, add 2 to both sides, x equals 2. Look at what I figured out. I figured out that 0, 2, and 3 really are the answers to my question in part C. Okay? How do you think the engineer came up with the function of this model? To start at height 0 yards and end at 300 yards, later at height 0 yards, she had to multiply x by x minus 3. Alright, that would create my zeros at 0 and 3. Alright, so we're looking at creating the first heel. So to create the first heel, so 0 yards to 300 yards, and then again at 0 yards. So it wants to know, how does she get that? How does she get that first heel and come back down to my lowest point again? She multiplied x by x minus 3, and that creates my zeros at 0 and 3. Okay, that creates my zeros at 0 and 3. Now I need to talk about how she gets that little small heel. Alright, so the bottom of the heel at 200 yards, How did she create that? She multiplied x minus 2 squared. All right? Now, where did that negative 3 come from? She needed to multiply by negative 3 to guarantee the roller coaster's shape. All right? She needed that for the shape of the coaster. What is wrong with this roller coaster model at distance 0 yards and 300 yards? Why might this not initially bother the engineer when she is first designing the track? If you look at this, the model appears to, let me get this back up on here. Zoom out. Okay, so if you look at this, it appears to abruptly start. Like you guys know when you're on a roller coaster, you have a little ways that you travel before you start going up the hill. This graph doesn't show that. It just goes straight up, and then it comes straight down and ends. It comes straight down to my lowest point. All right, so here at 300 yards, it doesn't actually continue. We can't look at the underneath of the x-axis because that basically means negative numbers. So according to this model, it looks like it abruptly starts and it abruptly ends. Once again, you guys know when you finish a roller coaster, you usually have, once you come off that hill, you have a little traveling to do before you get back into the terminal where you started. All right? So that's what's wrong with this, is it does not show our smooth transitions to and from the big hills. All right. By manipulating a polynomial function into its factored form, we can identify the zeros of the function as well as identify the general shape of the graph. All right. So let's talk about this. Let me get a separate sheet of paper because there's some things I want to talk to you about. The degree of the polynomial function h, the one from the beginning of our lesson, our roller coaster. The degree of this polynomial is 4. I figured that out by looking at the highest exponent that I have on my x. All right? How can you find the degree of the functions from its factored form? All right, so when I factored it, this is how I factored it. factored it, this is how I factored it. So how can I find the degree of the function from its factored form? You are going to add the highest degree term from each factor. So this factor, all right? So negative 3 has a factor of 0. It's not raised to anything. X is raised to 1. X minus 3 has a factor of 1. X minus 2 has a factor of 1. And x minus 2 has a factor of 1. So then I would add these all together, and that gives me 4. So if I have the factored form of this, I can still find my degree of my function. How many x-intercepts does the graph of the polynomial function have? So for this graph, I had 3. I had 3 zeros here. Zeros of a function correspond to the x-intercepts of the graph of the function. In other words, where do they cross the x-axis? All right? There are 4 factors, but only 3 x-intercepts. Why is that? Well, because look, I have 1, 2, 3, 4 factors, but I only have 3 x-intercepts. The reason for that is 2 of them are the same, so we do not rewrite them. The x-intercepts of the graph y is equal to f of x are solutions to the equation f of x equals 0. Values of r that satisfy f of r is equal to 0 are called zeros or roots of the function. Some of those zeros may be repeated. Can you make one change to the polynomial function so that the new graph would have 4 x-intercepts? Could I change one of these? I could change one of these to x minus 1. And then I would have a 0. Alright? So it's just a matter of changing one of these x minus 2's. Alright. Graph each of the following polynomial functions. What are the functions 0, counting multiplicities? What are the solutions of f of x is equal to 0? What are the x-intercepts to the graph of the function? How does the degree of the polynomial function compare to the x-intercepts of the graph of the function? Alright, so we have a lot that we need to look at. Looking at this, if you remember, it tells me that I can figure out my degree of my function by adding my degrees. But I don't need to do that because it wants to know what are the function's zeros. So in other words, I need to tell what are my zeros. So x is equal to 0. I would set x minus 1 equal to 0 and x plus 1 equal to 0. So I have zeros at 0. X minus 1 is equal to 0. That would be x is equal to 1. And x plus 1 is equal to 0 means that x would be equal to negative 1. So I have zeros at negative 1, 0, and 1. So what are the solutions of f of x is equal to 0? So the solutions where would y equal 0? Y would equal 0 at negative 1, 0, and 1. What are the x-intercepts to the graph of the function? Once again, Where are the x-intercepts? Where they cross the x-axis? They would cross at negative 1, 0, and 1. Alright? Now, how does the degree of the polynomial function compare to the x-intercepts? So the degree, I do need to know the degree now. So I have a degree of 1, 2, 3. So how does that compare to the number of x-intercepts? It is the same. All right, now, guys, let's talk about how to graph this. At this point in time, you would have to plug in values. But because I know that I have a 0 at 0, so I know I'm going to have one here. I know I'm going to have one here, and I know I'm going to have one here. This is what my function would look like. Okay? It's going to look like that. All right, let's look at B. Where do you think the graph of f will cross the x-axis? And how do you think the repeated factor will affect the graph? Look at this. I have x plus 3, x plus 3, x plus 3, x plus 3. So what's going to happen? Where do you think it will cross the x-axis? All right, so let's look at our zeros. If I set all of these equal to 0, I get negative 3, negative 3, negative 3, negative 3. All right? So my solution of f of x is equal to 0. In other words, where does y equals 0? Because when I say f of x, I'm thinking about my y. It's negative 3. My x-intercept, I only have one x-intercept. It's negative 3. All right, the degree is 1, 2, 3, 4. In this case, the degree is 4, which is greater than the number of x-intercepts. All right, if I were to graph this, I have an x-intercept at negative 3, and my graph would look like this. It only touches the x-axis at negative 3. All right? This lesson's a long one, guys, so just kind of bear with me. All right, let's look at this next one, part C. All right, my zeros would be at 1, 2, negative 3, negative 4, negative 4. Okay? So my solutions to f of x is equal to 0 would be negative 4, negative 3, 1, and 2. My x-intercepts, where does it cross the x-axis? At negative 4, negative 3, 1, and 2. And the degree is 1, 2, 3, 4, 5. which is less than the number of x-intercepts. Okay? It's less than the number. It's one less. Why? Because I have one that repeats. Alright? So let's graph it. So I know I'm going to have one at 1. And I'm going to have one at 2. I'm going to have one at -3. And then one at -4. So this is what my graph would actually look like if I took time to find a bunch of points. It would look like this. Okay? And if I wanted to graph this on a calculator, it would look something similar to this. Alright, looking at D, let's look at our zeros. X squared is equal to, x squared plus 1 is equal to 0. I can't do that because it would be x squared is equal to -1. We don't take the square root of negative numbers right now, so there is not a 0 there. So then I have x minus 2, which would be 2, and x minus 3, which would be 3. Alright, so my solutions to f of x is equal to 0 would be 2 and 3. My x-intercepts would be 2 and 3. And then the degree is 2, 3, 4, which is less than the number of x-intercepts. Okay? It would be less than the number of x-intercepts because I have I can't find zeros at my x squared plus 1. Alright? I'm sorry, that's greater than. I was thinking opposite here. Alright, so I graph it. So I know I'm going to have one at 2. I know I'm going to have one at 3. And this is what my graph would look like. Okay? And I'm not drawing my graphs perfectly, and it's okay. Alright. Let's look at example number 2. Consider the function f of x is equal to x cubed minus 13x squared plus 4x plus 44x minus 32. Use the fact that x minus 4 is a factor of f to factor this polynomial. Alright, so if I do, and to save time, I'm not going to do, but I do expect you to try to do the long division. But if I do this, I get f of x is equal to, I'm using the factor of x minus 4, and I get x squared minus 9x plus 8. Alright, which then factors into x minus 4, x and x, 8 and 1, and they're both negative. Alright, find the x-intercept for the graph of f. So the x-intercepts would be, set all of these equal to 0. They would be 4, 8, and 1. At which x values can the function change from being positive to negative or from negative to positive? They can only change at 1, 4, and 8. So what this is asking me is, when can I go from positive to negative on my x-axis, and when can I go from negative to positive? They can only change here because this is where they cross that x-axis. To sketch a graph of f, we need to consider whether the function is positive or negative on the 4 intervals. X is less than 1, 1 is less than x is less than 4, 4 is less than x is less than 8, and x is greater than 8. Why is that? Because this is where the function can only change signs at the x-intercepts. So therefore, at these intervals, this is where I'm going to figure out whether it's going to go above or below the x-axis. Tell if the function is positive or negative on an interval between x-intercepts. We would have to evaluate the function at a single point in that interval. So in other words, I would have to say, okay, my interval is x is less than 1, so I would put 0 in there, or I would put negative 1 in there. If 1 is less than, x is less than 4, then I would choose 3 and evaluate my function. For x is less than 1, is the graph above or below the x-axis? How can you tell? All right, so if I put in f of 0, if I say that I'm going to let x equal 0, plug it in. I get 0 minus 0 plus 0 minus 32. So I would get, if x is 0, y would be negative 32, so that means it is negative. All right? So for 1 is less than x is less than 4, let's do f of 2. I'm going to plug 2 in, so I get 2 cubed minus 13 times 2 squared plus 44 times 2 minus 32. 2 cubed is 8 minus 13 times 4 plus 44 times 2 minus 32. I get 8 minus 52 plus 88 minus 32. If I add and subtract all of that, I get 12. So it is positive, so it would be above the x-axis. Okay? Looking at the interval 4 is less than x is less than 8. Let's choose 5. Plug 5 in for x. Guys, I get negative 12. So since it's negative, the graph is below the x-axis. All right, and then x is greater than 8. If I choose 10, I get 108. Since it's positive, it would be above the x-axis. All right, so it wants us to graph this. All right, so we said we had zeros at 4, 8, and 1. okay? So if x is less than 1, so at 0, it was negative 32. So we'll go somewhere around in here so I can connect those. All right. Then we said if it was between 1 and 4, it was above the x-axis. So it would go up. And then I'm going to start to come back down, because we said that if f was 5, it was down here somewhere. And then I'm going to start coming back up because we said that it is above. So this is what my graph would look like. That is a rough draft of what our graph would look like. All right. Graph, they're telling us to graph it on a calculator. It would look the same, I promise you. All right, guys, this lesson has run really long. I'm not going to spend time reading the rest of this. I will tell you that it is super duper important that you read everything that is after this. It is going to tell you about the different types of graphs. It's going to tell you what they are going to look like. I do want to introduce you to 2 vocabulary terms. Make sure that you are reading this, relative maximum and relative minimum. We are going to be using that throughout the next several lessons. So once again, please make sure that you are reading all of the rest of this lesson. If you need help, reach out to me.